Okay, in this video, I have about 300 milliliters of ice water, and I'm trying to stir it to get an initial reading here, and it looks like we're getting awfully close to 0. There we go, 0.1. So again, I have a mixture of ice water, and what we're gonna do is put this on a hot plate and start looking at the change in temperature. Oh, look at that, we got 0 degrees Celsius. So let's put this beaker of about 300 milliliters of ice water, and the 300 is really not going to come into play today because we're not doing calculations. And let's see what happens. So at time 0, we had 0 degrees Celsius, and I'm just going to stir, and then about every 30 seconds, I'm going to do my second reading here in a second. I'm just stirring. Let's check out the temperature. And it looks like it's not even changing that much here. So, okay, 30 seconds later, we have 1.7. So let's measure 30 seconds later. And I think you can hear in here, I still have a bunch of ice inside of my beaker. So check this out. We're stirring. Okay. So it looks like 1 minute and 30 seconds. 2 degrees Celsius, so barely changing the temperature early on. And again, just by the jingling, I hope you can see that we have ice in there. So the temperature is not really changing much still. Now I want you to think about, while we're doing this, what is going on inside of this beaker as it's on this hot plate. Okay. 2 minutes, we had 2.5 degrees Celsius there. So look at that, the temperature is barely changing as long as I'm stirring my mixture here. Okay, I'm almost at 2 minutes and 30 seconds. Okay, so 3.6 degrees Celsius we had. Still barely changing, only by a matter of like a degree almost. This is almost freezing water still, everyone, inside of this beaker. How can that be when it's on a hot plate? Huh. Think about energy transfer now. Where is all the energy from the hot plate going? What is the verb you would associate with that? Okay, it looks like my ice is almost all gone. And my temperature is at, oops, it just turned off. I'll have to kind of restart here. 5 degrees Celsius. Okay. Ice is now gone. No more ice in here. Okay, 5. Now it's really starting to jump up. Like, wow, isn't that weird once the ice is all gone? Now we're at 9 seconds at 3 minutes and 30 seconds. Another 30 seconds later. It's important to try and stir this. Now we're at 14.8 degrees Celsius. Whoa, it already jumped up to. So at 4 minutes, we were at 14.8. Okay, at 4:30, we're at 19.8. The ice has been gone for a while now. We're at 26 degrees at 5 minutes. Okay, 32.6 at 5:30. $40 at 6 minutes. $44.8 at 6:30. It's starting to get uncomfortable to hold my hand here almost. Like, man, this is taking forever. Well, it's only been like 7 minutes. Okay, at 7 minutes, we're at 49 degrees Celsius. Okay, at 7:30, we're at 56.0 degrees Celsius. Now, I'm starting to see some bubbles on the bottom of my beaker, but I still wouldn't say that this is boiling because they're not all, like the whole sample's not bubbling yet. So at 8 minutes, we got 61.7 degrees Celsius, it looks like. We're getting close. What's happening to the molecules inside of this beaker right now, those molecules of water? What's happening to them right now? What are they starting to do? Okay, at 8:30, we're at 67.8 degrees Celsius. Remember, by the time I even start reading it, it's already going up again, so you just got to kind of do your best here. Okay, you know what? I can start seeing some steam building up on the side of my beaker, and I can also see like steam coming out of it. Okay, at 9 minutes, it was like 74.2 degrees Celsius. Okay, we're getting more bubbles on the bottom. Okay, at 9:30, we're at 77.8 degrees Celsius. I'm gonna go like this for a sec and start holding it with the tongs. I'm now seeing bubbles start to rise in the water. Okay, and at 10 minutes, we're at 84 degrees Celsius. Okay, at 10 minutes and 30 seconds, we are at 87.8 degrees Celsius. Remember, this hot plate is pretty good at giving us even flow of energy or heat here at a pretty steady rate. Okay, now I'm seeing a bunch of steam. I wonder if you in the video can see a bunch of steam starting to come out of here. And we're getting in the 90s now. Okay, 90, it's like even starting to fog up the reader here. 92 degrees Celsius at 11 minutes. Okay, now I would maybe describe this as like starting to boil. But until all of that water is bubbling, I really wouldn't consider it boiling yet. Okay, at 11:30, we're at 96.4 degrees Celsius. Okay, remember, there can just be flaws in these thermometers too. These thermometers might not be perfect. What I really want to see here, okay, at 12 minutes, we are at 99.2 degrees Celsius. Okay, now check this out. Now it looks like bubbles are forming from everywhere inside of this beaker. This is true boiling now. You know, we're at 99.3, 99.4. Now check it out. Is my temperature really going up anymore? Again, this could just be a flaw in the thermometer. Water usually boils at 100 degrees Celsius under perfect conditions with perfect water with, perfect thermometers and everything. And look, I'm adding heat to this water, but it is no longer going up. So at 12:30, our temperature was still 3 degrees Celsius. Let's just go for another minute here and see what happens to temperature. Okay. At 13 minutes. Remember, your graph might not truly represent this because I started the video at time 0. Okay, at 13 minutes, we're still at 99.3 degrees Celsius. So try and imagine what this graph would look like, and we are going to graph it in a second. Uh-oh, my thermometer turned off. And everyone, we're just going to call time, and the last temperature reading is still 99.3 degrees Celsius. So I want you to think about now, why is the temperature of the water no longer going up? What is all of the energy doing? Okay, so I would like you to now create a graph and then answer the questions that go along with this lab.